This ME110 product case study was performed by Alvin Choi, Mohammed Dean, Jason Ursepke, and Mark Mendwelin. The product being analyzed is an airsoft pistol.
For the barrel assembly, the majority of these parts were made by the process of injection molding. This can be determined by the visible parting lines, as well as the residual material left from the injection gates and various ejector markings. For the barrel end, the most likely process for making this section would be through plastic extrusion due to its smooth and uniform finish as well as cylindrical shape. Alternative processes for the plunger end can be done through thermoforming, as this part can be easily heated and formed into this shape by a mold. The downsides towards thermoforming is that while tooling costs are lower than injection molding, the production costs per piece would be much higher, especially significant in a product like this.
The plunger and the slider must be designed to fit within the cylindrical tolerance zone in order for the plunger to provide enough pressure to push the BB bullet through the barrel. If the plunger is too big, it will not fit into the slider and the bullet will not be pushed out of the barrel. If it is too small, the pressure will not be enough to push the bullet out.
We will now look at the outer casing of the airsoft gun. Similar to the other parts, the most likely method of manufacturing was injection molding. Here you can see multiple added ribbing lines used to increase the overall rigidity of the part, all with uniform wall thickness. In addition, many ejector pin marks as well as the parting line on top used to eject the part from the mold can be seen. Lastly, looking at the grip for the handle, you can see perfectly uniform pattern.
The next part of our device that we're going to analyze is the springs. There's 3 springs: the recoil spring, which is the medium-sized one, the magazine spring, which is the long and skinny one, and the hammer spring, which is the largest. I believe these springs to be cold wound, since there's no signs of heat marks which would have been left after tempering, which is required after hot winding a spring. Cold winding involves pushing a spring wire against a mandrel at a certain angle, which would force the wire to plastically deform into the desired coil shape. I believe the springs to be made out of stainless steel because of stainless steel's high accessibility and low cost. These springs don't appear to be shot peened, which will leave dimples along the surface of the spring. There's no corrosion-resistant layer on these springs either. An alternative process to cold winding these springs would be to hot wind them. This would allow easier manipulation of the wire, which would result in not needing to apply as much force to the mandrel bending the wire. The trade-off would be that the springs would need to be tempered after, since it would be brittle directly after being wound. This adds time and additional costs. An additional opportunity for GD&T to shine is in the barrel subassembly. Here, it's critical for the cylindricity of the inner barrel to be oriented perpendicular to the datum reference A in the photo. Otherwise, the airsoft pistol will shoot at an angle, creating potential for error, which could prove problematic for a pistol, even an airsoft pistol.